Hello, good evening everyone. Welcome to the sixth tutorial of this course. So in this tutorial I will be solving assignment 6 from last year's course, and if you have any doubts regarding the lecture videos, or if you feel anything you are not understanding during the tutorial, you can just unmute and ask, or you can write in the comment section. And so first few problems will be lengthy, so I will request you to solve it parallelly with me, otherwise it might get boring. Okay, so let me share the screen. I have shared my screen. If it is not visible, please let me know. Okay, so problem 1 is find the center of mass of a thin triangular plane bounded by the y-axis and the lines y equals to x and y equals to 2 minus x. If f of xy, so here this f of xy is basically this rho of xy, is the density, and f of xy is 6x plus 3y plus 3. Okay, so let's first draw the region. So y equals to x, will pass through these points. So this will be y equals to x line. This is the y axis, and y equals to 2 minus x. So for x equals to 0, it will be y is 2, so it will pass through this point, and for y equals to 0, x is also 2, so it will be passing through this point, and 1 points also satisfies this y equals to 2 minus x, so it will also pass through this point. So basically this straight line will look like this. This line is y equals to 2 minus x. And this triangular plane will be bounded by this y axis. So this is y axis, then this line, this y equals to x line, and y equals to 2 minus x line. So that means this will be the plane, and center of mass of this plane we are asked to calculate. Okay, so first of all, let's calculate the mass of this plane, where the density, I am writing it as rho, though it is given as f of xy, 6x plus 3y plus 3. So the mass will be, so we need to do surface integration, so we basically a double integration. So, and this rho of xy, then dy dx. So what this means, this rho of xy dy dx, it means at any xy, if you consider a small surface element, this is the dx dy, and if you are multiplying with, so this is an infinitesimal surface element, or if you are multiplying with this rho, that is the density, so you will get the mass of at this point, mass of this surface element, so you can call it the dm. And now if you sum it up throughout this area, so you will get the total mass. So that's basically what I'm doing. Where instead of summing, we are integrating here. Now let's put the integration limits. So here first we can integrate with respect to y. In that case, so we can take this area element and we can integrate with respect to y. So in that case, y limit will be going from, so it will be going from this line to this line. For any value of x, y will be going from this line, so y will be going from this line, y equals to x line, to y equals to 2 minus x line. So the limit will be y equals to x to y equals to 2 minus x, and with that, if we then vary the x axis, so x limit will be going from 0 to 1. So x limit will be going from 0 to 1. So basically we are here, by varying y, you are calculating this small area around this line, and now we are covering, so we are moving this area throughout from x equals to 0 to 1, and we are covering this entire area. That's the point of this limits here, and now we can directly integrate. So x equals to 0 to 1, y equals to x to 2 minus x, and this row of xy, this is 6x plus 3y plus 3, 6x plus 3y plus 3 plus dy dx. X equals to 0 to 1. So first we will integrate with respect to y, and so I will consider x constant. In that case, it will be 6xy plus the second term will be 3 by 2y square plus 3y, and here y will be going from x to 2 minus x times dx. Now I will put the limits. X equals to 0 to 1. If I put the upper limit, it will be 6x times 2 minus x plus 3 by 2 times, if I put the upper limit, it will be 2 minus x whole square, so that will be 4 plus x square minus 4x, and if I put the lower limit, it will be minus x square. And for the third term, it will be, if I put the upper limit, it will be 3 times 2 minus x, if I put the lower limit, it will be minus x dx. Okay. Cancel this x square with this x square. Also I can take okay, let's do one more step. So it will be 6 times 2x minus x square plus, so I can take this 4 outside from this term, I can take 4 outside, so it will be 6 times 1 minus x plus, from this term, so it will be, these two term will give minus 2x, so from there if I take 2 outside, so it will be 6 times 1 minus x. That is dx. Okay, so now if I take 6 outside, till x equals to 0 to 1, 2x minus x square plus 2 minus 2x.
Sir, one doubt, sir.
Yes.
Sir, subject the value y value, upper value, divided by lower value. First term 6x of 2 minus x
Okay.
after
Okay. Yeah.
minus
I
x.
made a mistake. Yes. There will be another minus x. Sorry. Yeah. Thanks. So it will be then 2x square. Right? So it will be 2x square. Anything else? No, I think the rest is fine. And this 2x will cancel. So it will be, if I take again this 2 common, then it will be 12 multiplied with x equals to 0, 0 to 1, 1 minus x square dx. So someone is raising hand, you can just ask in the comment section, or you can just unmute and ask. And if I do the integration, it will be x minus x cubed by 3. X equals to 0 to 1. Now if I put the limits, it will be 12 times 1 minus 1 by 3. So it will be 12 times 2 by 3. And so this is 4, it's 8. So the mass is 8. Okay. And now we are asked to find out the center of mass. So center of mass will have two coordinates. It will be, so let's define the center of mass as x bar, y bar. This is the location of center of mass. Then x bar is given by double integration of x times rho of xy dy dx divided by the mass. And similarly, this y bar will be given by double integral of y times rho of xy dy dx divided by the mass. And this integration limit will be same as this limit, because we are integrating over this region only. So I can first calculate m times x bar, which is basically this integration of x times rho of xy is 6x plus 3y plus 3. I can take 3 common, so it will be 2x plus y plus 3, sorry, plus 1 dy dx, and the integration limit will be y will be going from x to 2 minus x, and x will be going from 0 to 1. Okay, so first of all I will do the y integration. So I will take this 3 outside, and x equals to 0 to 1. I can put x here because we are not integrating here x, and the integration of this term will be, first term will be 2 of xy, and the second term will be y square by 2, and the third term will be y. Then the lower limit is, we are going from y equals to x to 2 minus x times dx. So it will be 3 to 0 to 1 x times 2x. So if I put the y upper limit, then it will be 2 minus x minus the lower limit minus x plus y square by 2. So then it will be half times, if I put the upper limit, it will be 4 plus x square minus 2x, and if I put the lower limit it will be minus x square, okay, plus if I put the upper limit it will be 2 minus x and the lower limit will be minus x dx. 3 x equals to 0 to 1 x, okay, it will be 2 times multiplied, so it will be 4x minus 4x square if I multiply 2x with this term, and this term will be, so this x square plus x square minus x square will cancel, and sorry, if I do the square it will be 4x, so it will be 2ab and a is x, b is 2, and there is a half here, so it will be plus 2 minus 2x, and this term will be plus 2 minus 2x. So now there is a 4x and there is a minus 2x and there is another minus 4, so this 3 term will cancel, and we are left with 3 times x equals to 0 to 1 x multiplied with 4 minus 4x square dx, and now I can take the 4 outside, then it will be 12 and x equals to 0 to 1 x minus x cube dx. Now if I do the x integration, it will be 12 times x square by 2 minus x to the power 4 by 4, and integration limit is x equals to 0 to 1. And now if I put the upper limit, it will be half, lower limit is 0. If I put the upper limit of this next term, it will be minus of 1 by 4. So half minus 1 by 4 is 1 by 4. That means this value will be 12 times 1 by 4 is 3. Okay. So m times x bar is 3. That means x bar will be, so x coordinate of the center of mass will be 3 by 8. Okay. Because 8 is m, the mass we have calculated here. So similarly you can calculate y bar, that is the y coordinate of center of mass. So center of, then I can calculate m y bar. So I am calculating this m times y bar, so which will be this integration in the numerator. So it will be y times, so this rho of xy is 3 times 2x plus y plus 1. So it will be 3 times 2x plus y plus 1 dy dx. Y will be going from x to 2 minus x, and x will be going from 0 to 1. So x will be going from 0 to 1. I put 3 outside, and I need to multiply y because minus x, and if I multiply y here, it will be 2xy plus y square plus y dy dx, and now we will integrate with respect to y. 3 x equals to 1 Now if I integrate with respect to y, then it will be y square by 2, and there is also 2 here, so it will be just x times y square plus this term, integration of this term will be y cube by 3 plus this term will be y square by, and y will be going from x to 2 minus x times dx, and 3 x equals to 0 to 1, or if I put the upper limit, it will be x times y square, that means 2 minus x whole square, so it will be 4 plus x square minus 4xy, sorry 4x, and minus this lower limit square, that means minus x square. Okay, now for this second term, if I put the upper limit, so I can write this 1 by 3 here, and now if I put the upper limit, it will be 2 cube, that is 8, minus 3 times 2 square times x, so that will be 3 times 4, right, so it will be 12x plus 3 times 2 times x square, that means it will be 6x square minus x cube. There is another lower limit here, so it will be then minus another minus x cube. For the last term, it will be plus half times y square, so same as this one, so this will be same as this one, because in case of y square I am putting the limits, and this term will be, if I can see this x square, then it will be 4 minus 4x overall multiplied with dx. Now if I do some simplification, then it will be 3 x equals to 0 to 1, then if I multiply it with x, then it will be 4x minus 4x square plus 1 by 3 here, then it will be 8 minus 12x plus 6x square minus 2x cube, and this term will be so plus 2 minus 2x. Now I can multiply to 3 also, in that case it's equals to 0, so because there is a 1 by 3, I don't want to deal with fractions, so in that case it will be 12x minus 12x to the power 4 plus 8 minus 12x plus 6x square minus 2x cube, and 3 multiplied to 6, 6 minus 6x times dx. So let's see which terms will cancel each other. So sorry, this is x square. This is x square. 3 multiplied with 4x square, that is 12x square. So this 12x will cancel with 12x, and there is plus 6x square, there is minus 12x square, so if I cancel this with this one, so we are left with minus 6x square. Okay. Then x equals to 0 to 1, for 14 minus 6x square minus 6x, so 14 is 8 plus 6, and minus 2x. Let me know if you find some mistake. Now if I do the integration, it will be 14x minus 6 by 3x cube minus 6 by 2x square minus 2 by 3, sorry, 2 by 4 x to the power 4, and x limit, lower limit is 0, upper limit is 1. Okay, so if I put the upper limit, it will be 14 minus 2 minus 3 minus 1 by 2, and lower limit, if I put it is 0. And in that case, 14 minus 2 minus 3, 14 minus 5 is 9. So it is 9 minus 1 by 2, so which is 18 minus 1 by 2, and 18 minus 1 is 17, so it is 17 by 2. 17 by 2. So m y bar is 17 by 2. That means y bar will be 17 by 2 divided by m, and m is 8, so it will be 17 by 16. So the y coordinate of center of mass is 17 by 16. So center of mass coordinate will be x bar, y bar is to y coordinate is 17 by 16, and x coordinate is 3 by 8. 3 by 8. So this will be the center of mass, 3 by 8 and 17 by 16. Second one. Okay. The next problem will also be a little bit lengthy. I will try to go a little bit fast here. So here we have to calculate the same, like center of mass of a thin plate bounded by x-axis and the lines x equals to 1, x equals to minus 1, and the parabola y equals to x square, and the density is given by 7y plus 1. Let me first draw the region where we have to integrate. So this is x, this is y, and let's first draw the parabola. This is y equals to x square. So it means it will, so 0 0 point satisfies here. That means it will start with 0 0, and now whether you will whether you can decide, I mean, whether it will be like this, or whether it will be like this, or whether it will be like this or this, by just looking at the equation. Like for y equals to x square, you can see x can be positive or negative. So it can, so x can allow x can be in this side or this side, but y will always be positive. Okay, and as x tends to infinity, y will also tends to infinity, positive infinity. X can go to either negative or positive infinity, but in both cases y will be going towards positive infinity. So the parabola will be this one, like x can go here, x is going negative but y is positive, and in this case x is positive, y is also positive. Okay, but I mean it cannot be like this, because here y can also y can go negative. It cannot be like this. In this case y can also go negative. It cannot be also like this, because here also y can go negative. And the other bounds will be x-axis, so this line, and x equals to 1, so let's call this as 1. This is x equals to 1, so this is the line, and other is x equals to minus 1. Let's call it minus 1. This is the line. Okay. So this is the region of which we are asked to calculate the center of mass. So first calculate the mass as usual. So it will be double integral of rho of xy times dy dx. Okay, so rho is, I'm calling this delta, I'm calling as rho, and this is 7y plus 1. And now let's put the limits. So the limit will be, we will be integrating throughout this area. So in that case, we can, at any value of x, we can calculate a small area element dx dy, and now we can run it from this line, from x-axis to this parabola, that is y equals to x square. Okay, so y will be going from, so if I move y, so y will be going from this line to this y equals to x square. So y will be going from 0 to y equals to 0, that is x-axis, to x square. And now now I will move this small elongated region throughout x equals to minus 1 to 1. So in that case, it will cover the entire area. So x will be going from minus 1 to 1. Okay, so as we are moving along, this length will depend on x. So it will get elongated here, it will get shrink here, and it will cover the entire area. So let's put the value of density. X equals to 1, 1, minus 1 to 1, sorry. Minus 1 to 1. Y equals to 0 x square, and this rho will be 7y plus 1, 7y plus 1 dy dx. Now if I do the y integration, it's equals to minus 1 to 1. Oh, sorry, I'm doing the y integration. So it will be 7 by 2y square, integration of the first term, and integration of the second term is y. And if I put the limit, y will be going from 0 to x square times dx. Okay, so now x equals to minus 1 to 1, and if I put the upper limit, it will be 7 by 2 times y to the power 4 plus y square, because if I put the lower limit, it will be 0, sorry, x square. So if I put the upper limit, it will be x to the power 4, and this time will be x square times dx. Now I will do the x integration. So it will be 7 by, so there will be 1 by 5 coming, so it will be 7 by 10, so it will get multiplied the 2, and x to the power 5 plus x cube by 3, integration of the second term, and x will be going from minus 1 to 1, and if I put the upper limit, it will be 7 by 10 plus 1 by 3, and if I put the lower limit, it will be the same value, because there is a minus sign, because we are putting the lower limit, and there will be minus sign coming from this to the power 5 we are putting it, so there will be minus sign coming from there, so it will be twice of this. If I do the summation, it will be 30, and it will be 21 plus 10, so it will be 31 by 30. So this is the mass. Okay. Now we need to calculate the center of mass coordinates, that is x bar comma y bar, and x bar y bar is defined same as the first problem. So like this. Okay, so first I will calculate m times x bar, which is this integration, and then I will calculate m times y bar, which is this integration, and then I will divide by m. So m times x bar will be rho of xy x times dy dx. Y will be going from 0 to x square, and x will be going from -1 to 1. And now you can easily guess what will be the integration value. So this rho of xy, this is actually is not a function of x, it is actually a function of y. Okay, so it will be a function of y. So in that case, you can see the region is symmetric with respect to x axis, so it will be -1 to 1, and this density is only proportional to y, so it will not breaking the x symmetry. So in that case, the x coordinate of the center of mass will be at the center, I mean will be at x equals to 0. Okay, so this you can easily guess from here. If you calculate it, you will also get 0. So -1 to 1, I can take it x outside, I will integrate y equals to 0 to x square, and this rho of xy is 7y plus 1. So 7y plus 1 dy dx. Right. Now if I do the y integration, -1 to 1, and if I do the y integration we already did here, this will be the same y integration. So it will be 7 by 2 times x to the power 4 plus x square. Okay. It will be x times, so it will be x times 7 by 2 x to the power 4 plus times x square plus x square. So now you can see this is this whole function, it's an odd function of x. Okay, and now we are integrating it from -1 to 1, and this integration will be 0. It's an odd function. Now, so in that case, x bar will be 0. This is the x coordinate of the center of mass. Now let's calculate the y coordinate of the center of mass. So let's calculate m y bar, which will be rho is 7y plus 1 times y dy, sorry, y dy dx, and y will be going from 0 to x square, and x will be going from -1 to 1. So if I multiply with y, it's 1 to 1. If I multiply with y, it will be 7y square plus y dy, y equals to 0 to x square dx. Now if I do the y integration, it will be, so writing the x integration values, and if I do the y integration, it will be 7 by 3 times y cube plus half times y square lower limit is 0, upper limit is x square. It will be x equals to minus 1 to minus 1 to 1, and then if I put the upper limit, it will be 7 by 3 times x to the power 6, because I'm putting x square instead of y, and it will be half times x to the power 4, and the lower limit if I put it will be 0. As dx, if I do the x integration here, it will be 1 by 3 times x to the power 7, because there will be 1 by 7 and this 7 will cancel with each other, and then it will be 1 by 10 times x to the power 5, and x will be going from minus 1 to 1. If I put the upper limit, it will be 1 by 3 plus 1 by 10, and if I put the lower limit, there will be a minus sign because of the lower limit. If we are putting the lower limit, so minus of this lower limit, and because this is x to the power 7 and x to the power 5, so there will be minus sign coming, so it will be same as this term getting added with this, so it will be just twice of that. Sir, diagram please explain. So diagram means the area how I am calculating the limit, right? This diagram. Let me explain it again. So we are asked to calculate the center of mass of this region. So this is the region. Okay. So this is the y equals to x square parabola, and this is y x axis, so y equals to 0 line. This is the x axis. So this line is basically y equals to 0, and x equals to 1. This is x equals to 1. This line is x equals to 1, and this line is x equals to minus 1. So all these 4 lines, the area bounded by these 4 lines is this this green, this blue shaded region, and the density, mass density is given by 7y plus 1. So here I am calculating first the mass, which is the double integral over this density, and now how I am writing the limits. So at any x value, so this is the dm, this is the dm at any, so at any xy value, if I consider a small area element, this is the dx dy, okay, and this, the mass of this area element is a dm, okay, and now I am summing over the whole region. That's the meaning of integration. So how I am summing it over this complicated region? How to take limit value of x and y. Okay, that's what I am explaining here. So this is the dm, and now I will integrate over this region. So how I am doing that? So first I am integrating over y. So in that case, for any x value, if you choose any x value, let's say at some arbitrary x value, and now I am integrating over y. So in that case, y will be going from this line, like y equals to 0 line, to this curve. So for at any x value, so this y, if I do the y integration, I will get this area, this small area patch, basically. So how I am getting it? By integrating from this line to this line. So integrating from y equals to 0, this line, to this y equals to x square parabola. So y limit will be going from for any x, y will be going from 0 to x square. And now if I move now, as so for depending on the x value, So this region will get elongated. So at this x value, this will look like this. At this x value, it will look like this. At some x value, it will look like this. Okay. So now if I move this x value from -1 to 1, it will basically cover the entire area. So this elongated area patch, it will just cover the entire area, and this its length will be here it will be elongated, it will be, and here it will be shrinked, and then here it will be again be elongated, and it will cover the entire area. So that's how I'm covering the entire area and integrating through it to calculate the total mass. If you are not understanding, then let me know. I will explain it again. So first I'm going integrating y, so I'm considering a small area element. This pink one is that. This is the dA, and now I am integrating over y. So and y limit will be depending on x. So then, I mean, depending on x, y value will be going from 0 to, so for this x value it will go up to this point, for this x value it will go up to this point. So y limit will be depending on where at which x point we are at. So that means y will be going from y equals to 0 to x square. So at this, and then I'm moving it throughout this x region. Okay, so if anyone have any problem of understanding how I am covering this area, please let me know. I'll explain it again. So here this m y bar is it will be 30 times it will be 10 plus 3, that is 13 times 2, that is 13 by 15. Okay, this is the m y bar, and then y bar will be 13 by 15 divided by m, and where m is 31 by 30. M is 31 by 30. So it will be 26 by 31. Okay, the options are not matching. I made some mistakes somewhere. Y integration.
M should be 31 by
M should be 31 by 15. Okay, there is a 2 multiplied here. Yeah. Thanks. So this is the M we are calculating, and so this sum is 21. So 7 times 3 is 21 plus 10 by 30 and times 2. So it will be 31 by 15. Yeah, M is 31 by 15. So here number 15, it is 13 by so the center of mass coordinate will be x bar y bar 0, 13 by 30. Third option is the correct one. How do we find the moment of inertia along the x-axis or the y-axis? Okay. So definition of moment of inertia. let's say this is some axis. Let's say we are asked to find out the moment of inertia around y-axis, for example. Okay. Now this is some region for which we are asked to find out the moment of inertia. So we can consider a small infinitesimal area dA. This is moment of inertia around, let's say, y-axis. Okay. So for example, first of all, let me start with the basic. So let's say there is a point particle of mass m, and it is at a distance y from the x from the y-axis. Distance x from the y-axis. So what will be the moment of inertia of it? It is defined as m times x square, okay, with respect to y-axis. And with respect to x-axis, then it will be, so I of x, it will be, if the distance is y, then it is m times y square. Now, instead of a point mass, if I have an extended object, extended mass distribution, this x, this y, and instead of a point mass, let's say I have a mass distribution. And for example, we are asked to find out the center of the moment of inertia. We are asked to find out the moment of inertia with respect to y-axis. So Iy we are asked to find out. So for example, to do that, first we will calculate. First we will take a very small area element. So property d, which is dx dy in Cartesian coordinate. Okay. So this is an infinitesimal area. So we can consider it as a point particle. Okay, as a point object. That's the infinitesimal meaning in calculus. And if the density is, let's say, rho of xy, so in that case the mass of this infinitesimal area, it will be dm, right? So mass will be, if I can call it dm, so it will be rho times d, density times the area. So now if you are asked to calculate the moment of inertia with respect to y-axis, the distance from this infinitesimal area from y-axis is y. So this is the y coordinate. So this is situated at coordinate xy, right? So then the moment of inertia of this small area element, infinitesimal area, around y-axis, that will be, let me call it d of Iy, which will be y square times dm. So I can consider for this infinitesimal area, I can consider it as a point object. Okay. So and for point object, what is the definition of moment of inertia? That is mass times y square. And similarly here, the mass of this infinitesimal area is dm, so it will be dm times y square. So this is the moment of inertia of this infinitesimal mass element, and this dm is basically y square rho of xy times dy dx. Okay, and now if we, so this is the moment of inertia of this small area element, and now if we want to calculate the moment of inertia of this entire distribution, so in that case what we will do, we will just do the integration. So double integration d of I, so this will be double integration of this y square rho of xy dy dx, and now depending on the region we will put the limits. Similarly, if one has to calculate the moment of inertia with respect to x-axis, so in that case you will take this small area element and the distance from x-axis at a point xy, an arbitrary xy point, so the distance will be x. The moment of inertia of this small area element will be d of ix will be x square times dm. So moment of inertia with respect to this x axis. Sorry. So if this is the point mass, the distance from y axis is x. Extremely sorry. So here the distance from y axis is x, right? If this is the coordinate xy, sorry. So this is the coordinate of this point xy. So the distance from y axis will be x, and distance from x axis will be y. So in that case, the moment of inertia of this point or whatever you say infinitesimal mass with respect to y axis will be this distance from perpendicular distance from y axis, that is x square. So x square times dm times the mass. So this is x square times the mass, and then for the integration it will be x square times this one. And for moment of inertia with respect to x axis, so perpendicular distance of this point mass or this infinitesimal mass is y from x axis, so it will be y square times the mass of this mass element, that is dm, and it will be y square times rho of xy dy dx. So I of x will be y square times rho of xy dx, double integration. Okay, and the region you can just decide depending on this. The limit you can decide depending on this region. It's already 1 hour. The next problems will not be that much lengthy. So third one is find the line integral of this vector field. The vector field is given by root under z I cap minus 2x j cap plus root under y k cap. From this 0 0 0 point to 1 1 1 point over the path this. So this path, so this is the path, this is the origin. So at each point of the path is defined by this r vector, this radius vector. So this is the origin. R is a function of x, y and z, but as it is a curve, that means it's a one parameter object, so we can always write this r as a function of one parameter, that is t here. Okay, so r in terms of x, y, z coordinate will be x I cap plus y j cap plus z k cap, and as it is a one parameter thing, so that means this x, y, z all will be depending on that parameter t, right? And here that form is given, so this is the path given, so that means r is given as t I cap plus t square j cap plus t to the power 4 k cap, sorry, t square is k cap. So you can see the x coordinate is basically t, x coordinate is t, just by looking at this simple equation, and y is t square and z is t to the power 4, z coordinate is t to the power 4. So this is the z coordinate, this is the y coordinate, this is the x coordinate. Okay, then r is, okay, r is already given, that is t I cap plus t square j cap plus t to the power 4 k cap. Then dr will be small if I just move a small distance. remove just a small distance. So this is the dr. This dr will be dt I cap plus 2t dt. This is the differential distance. So dt, and I can take dt just outside. So it will be I cap plus 2t j cap plus 4t cube k cap times dt. Okay. This is a dr and this vector field. So vector field is given all over the region, but this line integral should be calculated along this path C. So that means this x, y, z, that will be restricted by this parameter equation. Okay. Only then this f will be on along this path. So then f will be, I can replace by a function of t. So root under z, and z is t to the power 4. So it is t square I cap plus y component is minus 2x and x is t. So it will be minus 2t j cap, and z component is root under y, and y is t square, so root under y will be t. That means it is t cap. Okay. So then the line integral will be, call it I. Line integral will be integration along this curve f t dot dr. And if I do the dot product, so this is the dr. If I do the dot product, then this I component will get multiplied, x component, that means it is t square, and then this y component will get multiplied. So it will be 4t square, and there is a minus sign, so it will be minus 4t square, and then if I multiply the z components, it will be 4t to the power 4. 4 to the power 4, and this whole thing is multiplied is dt, because in dr there is a dt here. And now I need to put the limit. Okay, so limit, and as I am integrating with respect to t, so I need to put the limit with respect to t. So let's look at the region. So here, okay, the limit is already given, that is from 0 to 1, and you can also see that if you put t equals to 0, so you are at this point. So this is 0 0 0, that means you are at this point, and if you put the t equals to 1, you are at this point, 1 1 1. So t will be going from 0 to 1. Now this is simple integration. It will be t cube by 3 minus 4 by 3 t cube. I can do the subtraction first. So it will be minus 3t square. Minus 3t square. So in that case it will be minus 3 by 3 t cube plus 4 by 5 t to the power 5, and the upper limit is 1, lower limit is 0. So this, I put the upper limit, it will be minus 1, plus 3 cancels, and this plus 4 by 5, lower limit if I put it will be 0. It will be minus 1 plus 4 by 5, that is minus 1 by 5. This is the line integral. Minus 1 by 5, so not 4 by 5. This is the minus 1 by 5. The next problem, a line integral of a vector field f defined on D is path independent if f can be expressed as gradient of some scalar function. So this f is the scalar function. This f is the scalar function. This is the gradient vector. Okay, so line integral you can define it like line. So let's say there are 2 points. This is point 1 to point 2. Okay, then I line. Let's say there is one path. There is another path. Let's say there is C1. So this is C2. So let's say you are going from C1. You are going along the C1 path. The line integral will be f dot dr. So then C1. So f is some gradient of scalar function dot dr. Dr is dx I cap plus dy j cap plus dz k cap, and this grad of f I can write it as del f del x I cap plus del f del y j cap plus del f del z k cap times dot product with dx dx I cap plus dy j cap plus dz cap. So now this is basically the chain rule you can recognize. So it will be del f del x dx plus del f del y dy plus del f del z dz. This is same as df, or you can write it in a different fashion, right? You can define a parameter t because you are going along a curve. Let's say the curve parameter is t. So in that case, from C1, so then x, y, and z they will depend on t. So in that case, you can write it as this dx. You can write it as dx dt times dt plus del f del y dy dt times dt plus del f del z. It is not required actually. You can directly write a df. C1, and this is, if I take the t common, then this is basically a chain rule of this derivative f of x y z dt times dt. Okay. And this, if I do the integration, it is basically df C1 and integration of df is f, and the limit will be from 1 to 0.1 to 0.2. So this f, so it will be f at 0.1. So f at 0.1, let's say, sorry, f at 0.2, then let's say x2 y2 z2 minus f, the scalar function at point x1 y1 z1, right? So this line integral, it depends on the values of the scalar function at the starting point and at this ending point. So this is the starting point and this ending point. So it doesn't depend on which path you are taking. So the final result is depending on this ending point minus the starting point. And then the statement is basically line integral is independent of the path. Okay, that statement is true. As you can see, this line integral is basically scalar function, the scalar function at point 2 minus the scalar function at point 1. Here we are to calculate the work done by this force over a straight line from this to this. So let me define the line. This x, y. This is the 1, 1. This is the 2, 3. This is the line. This is the 1, 1. So I can calculate the equation of this line. So equation will be y minus y coordinate of this point is 3 divided by y minus y coordinate of this point, that is 1, equals to x minus x coordinate of this point, x minus x coordinate of this point. Okay, or you can remember it like this also. For example, let me take at some point xy, some arbitrary point, or let me extend this line. So some arbitrary point xy. Then if I consider this point 2, 3, then the slope of this line will be y minus 3 divided by x minus 3, x minus 2. And if I consider this point, the slope will be y minus 1 divided by x minus 1, and they should be equal. This is the equation of this line. And if I do the multiplication, it will be xy minus 3x minus y plus 3 equals to xy minus 2y minus x plus 2. So this xy cancels, and if I take this y this side, then it will be just y because there is a minus y, and if I take all this x and this plus 3 on the right hand side, then it will be 2x minus 1. Okay, so equation of this line is 2xy equals to 2x minus 1. So I can write x as a parameter. Okay, so then this r vector is displacement vector is x I cap plus y j cap equals to x I cap plus y is 2x plus 1, 2x minus 1, so plus 2x minus 1 j cap. Now this dr will be dx I cap plus 2 dx j cap, and this f will be, this vector field will be xy I cap, x y, and y is 2x plus 1, 2x minus 1, so 2x minus 1 I cap plus y minus x plus y is 2x minus 1 minus x j cap, and if I do the multiplication, it will be 2 times x square minus x I cap plus this will be x minus 1 j cap. So the line integral will be, or work done, what was the work done? So the work done will be w is integration f dot dr from this point 1 to point 2. Let me call it point 1 to point 2. So from this point, each start point to ending point. Okay, so if I do the dot product, it will be 2x square minus x times dx plus x minus 1 times 2 times dx. So it will be 2 times dx, and the limit, so as I'm writing in terms of x, the limit I will write as, so x will be going from, if I'm going from 1 1 to 2 3, x will be going from 1 to 2. So the x limit is 1 to 2. So as I'm integrating with respect to x, I can just write the limit in terms of x. And so it's equals to 1 to 2, and if I do this, it will be 2x square minus x plus 2x minus 2 times dx, and it will be, so this will be x equals to 1 to 2 is 2x square plus x minus 2 times dx. Now if I do the integration, it will be 2 by 3x cubed plus x square by 2 minus 2x. The limit will be 1 to 2, and if I put the upper limit, it will be 2 to the power 3, that is 8 times 2 is 16 by 3, minus 1 minus 2 by 3 if I put the lower limit. Then the lower upper limit here, it will be 4 by 2, that is 2 minus half the lower limit, and if I put the upper limit here, it will be 4 minus 4 plus 2. So there is 4 here, minus 4 here, and there is plus 2 here. Cancel it, and this 2 term I can write as 14 by 3. So basically this is 14 by 3 minus half, which is 6, and this 28. This is 28 minus 3, that is 28 by 3, that is 25 by 6. Let me check. Yeah, 25 by 6. So this is the correct one. The first option is the correct one, 25 by 6. So the work done will be 25 by 6. The next problem, the parametric equation of a surface is always unique, whether it is true or false. So it is, you can just try for a simple parametric equation of a surface like parabola. Sorry, its equation is y equals to, so this is x square equals to 2ay. This is how it's written. So x can go positive or negative, so x will take the square basically. Y cannot go negative, so y is not taking the square. This is how you can remember what form it will be. And okay, so parametric equation of this. So to prove something wrong, you can take an example and show that okay, this is not valid. That means it is wrong. So it's one parametric equation might be like the standard is x, I can say 2at, and y will be in that case 80 square, right? No, this is, the equation is then 4. This is 4. So this is the equation of this parabola. Then this is one parametric equation, like x equals to 280. So if I put x square, then it will be, on left hand side will be 4a square t square, and here if I put y value, it will be just match with that 4a square t square. but I can also consider y as t. I mean, then or x as t, or some s. So x as some s. S is the parameter, then y will be like s square divided by 4. Or instead of 280, I can consider instead of 280 I can consider anything like for example 80 also I can consider. So in that case y will be if it is 80, so then y will be 1 by 4 80 square. So this choice is not unique basically, so any kind of parameter you can choose. So this is even for a line, so even for a surface also this is not true. So this statement is false. The choice of parameter is not unique. Which of the following is a parameter representation of the portion of the cylinder y square plus z square equals to 9 between the planes x equals to 0 and x equals to 3? So let's draw the cylinder first. This is the yz plane, and this is the x-axis. So let's assume yz plane is in the plane of this screen. Then the cylinder spherical, this part, this y square plus z square equals to 9 will be a circle like this with radius. So this radius is basically r equals to 3. It's 3 square. Okay, and this portion is dotted. So it will look like this. So x equals to 0 is this plane, and let me call it this plane as x equals to 3, and this plane is x equals to 0 at x equals to 0, and this equation, this line is basically y square plus z square equals to 3 square. Okay, so at any point, so so if you look at these options, I can define point on this circle, and the distance from the center will be, or distance from x axis will be 3, and I can define this angle as u, right? Because this angle, okay, here somewhere they are defining angle as u. Okay, I can define this angle as theta. So in that case, y coordinate will be, or on this cylinder, y coordinate will be 3 cos theta, and z coordinate will be 3 sin theta. So this will be the z coordinate. This is 3 sin theta, and this base is 3 cos theta. And if you want to roam around this this plane, so this yz coordinate, it will take us to this circle, and now if we roam around this plane, we need to specify the x values, and x will be moving from 0 to 3. So on that case, we'll stay on the cylinder. So x will be, so another is basically x, another coordinate is x, where x will be going from 0 to 3, and this theta will be 0 to 2 pi to cover the whole region. So theta will be 0 to 2 pi. Okay, so here I should search for okay, angle. So angular coordinate will be same, so the last option is like this. So this is 3 cos v y coordinate. So here the theta is basically v, so here theta they are representing as v. So in that case, y equals to 3 cos v and z equals to 3 sin v, where v will be going from 0 to 2 pi, 0 to 2 pi, v is going from 0 to 2 pi, and x they are representing as, they are defining another parameter like u, and this u will be going from 0 to 3. So that means you will cover this cylindrical surface. So this x they are defining as u, and u is going from 0 to 3. So the idea is while roaming, moving along x from 0 to 3, you have to be along this on this circle, that is x square y square plus z square equals to 3 square or 9. So the last option is the correct. Now the next one is, which of the following parametric representation of the portion of the plane inside the cylinder? Okay. So the cylinder is x square plus y square equals to 9. So this is the x, this is the y, this is z, this is the cylinder of radius 3, the cylinder of radius 3, this length is 3, and let me draw the plane also. And being inside the cylinder, we have to be on this plane also. So the plane is basically, let's say this is 1, this is 1, this is 1. So equation of plane is x equals to x plus y plus z equals to 1. So that means it will be, for when yz equals to 0, x is 1. So it will cut the x axis at 1. Similarly, it will cut the y axis as 1. So the plane will look like this. This is the plane. So first, what you need to do is, you need to be, so the idea is basically, so let's say this is the plane. Okay, so idea is basically, first you need to be at any point on this xy plane. Okay, we should be inside this cylinder. First you come to the so this is that z equals to 0. So at z equals to 0, this plane, this base, you should come at any point xy, which is inside this cylinder, and then you will go at a distance z, which is on the plane. So on that way you can be on the plane and inside the cylinder. So if the argument is not clear, please let me know. So first what you need to do is you need to be at some point which is inside the cylinder, okay, at some point on the z equals to 0 plane. So in that case, as it is a circular bounded region, so the basic instinct will be like x equals to r, to use the plane polar coordinate for the plane polar coordinate. So r cos theta, this is the, for example, x and y. Okay. So this is the r and this is the theta. This is the theta and this is the r. So x equals to, then x will be r cos theta and y will be r sin theta. So in that way you can be at any point on this z equals to 0 plane and inside the cylindrical region. Okay, so here r will be varying from 0 to 3, so 0 to this radius, so 0 to 3, and theta will be varying from 0 to 2 pi. So in that case you are always inside this cylinder and you are on this z equals to 0 plane. Now the idea is you need to be inside this cylinder and also on this plane. Okay, so you need to take a z axis, you need to take a z movement which should satisfy this equation. So at any point the xy coordinate is given by this, so the z point should satisfy this equation. So then the z point will be 1 minus x minus y, which is 1 minus r cos theta minus r sin theta. So at any point xy, if you take this z movement along the upper direction, so then you are on this plane. So basically at the end of the day you are on this plane and you are inside this cylindrical region. Okay, so the correct option is x equals to r cos theta, y equals to r sin theta, z equals to this. Yeah. Second option is the correct one. Because radius is 3, so you should be inside this radius and theta should be going from 0 to 2 to cover the entire region. The parametric equation of this paraboloid, so this is also kind of easy. So equation of this paraboloid is, this is x and y. This will parabol to the z axis. This is at any z, if you take at any z equal to, if you put the z equals to constant, so then this is a circle basically. So in that case the basic idea will be we should use so at any value of z, the radius of the circle is root under of z. So if I take z as u square, let's say z as u square, so at any value of z, the radius of the circle will be, so this equation is basically x square plus y square equals to u square, then because x square plus y square is z, that's the equation of this paraboloid. So in that case at any point if you come at any point z, so then the radius of this circle which cuts the which is the cut of this z plane and this paraboloid, this is u, this radius is basically u. Okay, when z is u square, and from there you can just, to be on this on this circle, just take the plane polar coordinate, and that is u is the radius, so u cos theta, and y is u sin theta. and instead of theta they are using v. So instead of theta they are using v, so it is cos v sin v. So x is u cos v, third option u cos v, y is u sin v, and z is u square. And the last problem is, if the field F is conservative in region R, then at a closed loop, take a closed loop, so then say C. This is a closed loop. So in that case, we are asked to show that around this closed loop C, f dot dr is 0. It's very easy to prove. So the definition of this conservative field is basically f can be represented as a gradient of some scalar function f. Okay, and then you can take any 2 points on this loop. Let's say this is point 1 and this is point 2, right? And you can define this path as, so you can define this path as, while going from point 1 to 2, you can define this path as C1, and while coming back you can define path as C2. So you can divide this integral, like integration closed integral f dot dr, into 2 parts. So this is we need to prove. We don't know whether it is 0 or not still till now. So this closed integral we can define it in 2 parts, like from going from point 1 to 2 and then point 2 to 1. Okay, so then it is from point 1 to 2, let's say along the C1 path. Along the C1 path, someone is saying, when you will upload this video? Today I will do that, maybe 1 or 2 hours after the class ends. And f, so this is f dot dr plus, while coming back, so let's say around curve C2 from 1, f dot dr. And now we have already shown that if f is given by this gradient of a scalar function, so then this integral will be, this first integral, it will be nothing but the value of this scalar function at point 2. So value of the scalar function at point 2 minus value of the scalar function at point 1. Similarly, this integral it will be the value, this integral will be the value of the scalar function at point 1 minus the value of the scalar function at point 2. This is already we have proved in this tutorial. Okay, and there is some plus sign, and you can just very easily can see, like this plus, this minus will cancel, this plus and this minus will cancel, and it will 0. So if you have a conservative field and this is the force, if you have a conservative force and you are you take a closed path, then you are not doing any work. Basically, that's the meaning of this this equation. The work done, this is the work done, and work done is 0 around any closed loop. The force field is conservative. Okay, so that's all for today. If you have any doubt regarding any of the problems, you can just you can ask, or you can write in the comment section. Find the work done by F over the curve in the direction of increasing t. Okay, I can give you the hint. So a similar problem actually I did. So this is the curve. Okay, if you want to know how the curve will look like, let me draw it for you. This is x, this is y, this is z. And as you have written r, so r is given by sine t I cap plus cos t j cap plus t k cap. Okay, so the x coordinate is sine t and y coordinate is cos t and z coordinate is t. So these kind of paths are called like helix. So this so this x equals to sine t and cos t suggests that you will be moving along a moving along a circle. But while moving along a circle, the z will be increasing with t. So as we are moving along with uh, increasing t, the z will also be increasing. Just it will look like this. So the path will look like this as you are changing your t, and you will start from y axis. Sorry. So when t is 0, then you are at y equals to 1. So you start from here and you move upward. Like this, you move upward. Okay. So your dr will be infinitesimal. At any point the infinitesimal path will be this dr, and this dr will be cos t. If you do the differential, then it will be cos t I cap plus minus sin t j cap plus k cap and whole multiplied with dt, and your f will be, so you are moving along this line, so that means your x y z, this cannot take any value, they should be bounded by this parameter, restricted by this parameter. So that means though your force field it is given as z I cap plus x j cap plus y k cap, while you are moving along this curve, this x y z will be restricted by these values, like this parametric equation. So z is t, so t I cap plus x is sin t j cap and y is cos t k cap. And now you can just calculate the integral. Line integral will be, or work done will be, integration f dot dr, and t is going from 0 to 2 pi, t will be 0 to 2 pi. If you do the dot product, you will get something like t times cos t, t times cos t. Yeah, I think the rest you can figure it out. Just do the dot product and just do the integration with respect to this limit. Anything else? Okay, if not, then I'm stopping the screen share. Thanks for joining. Okay, if there is nothing, then I'm ending the class. Bye.